Alright, what's going on, guys? In this video we're going to be doing some final review for college algebra. This is going to be the part 1 of 2 videos, and each video I'm going to have 25 problems that we're going to be going through in depth, and that of course adds up to 50 problems total that we're going to be going over between these 2 videos. Okay, before we get into what topics we're going to be doing in this video, I really want to make sure that you guys are subscribed to this channel because I have, a bunch of new content coming out all the time, and that could also help you in later math classes as well. And I also do physics videos, so definitely subscribe for that stuff. Now, let's get into the topics that we're going to be doing in this video. So the topics that we're going to be doing in this video are mainly going to be, a combination of Algebra 1 and Algebra 2, right? We'll kind of start off with the more Algebra 1 stuff with solving algebraic equations. These are essential to being able to do a lot of the stuff that is covered in college algebra, right? We'll move on to inequalities and absolute value equations. We'll talk about polynomial functions, factoring, all that good stuff. We'll talk about completing the square and quadratic formula. And then we'll move on to lines and circles. Then lastly, we'll talk about properties of functions. Okay, and got a lot of good problems there, definitely. All right, and as you can see on the left here, I have all the timestamps for, each of these topics if you want to jump to a specific one that you definitely feel that you're struggling with. So now that that's been said, let's move on to our first section and our first problem, which is on solving algebraic equations. So I tried to go with a much nicer problem to start off with. All right, so this problem is asking us to solve for x where 4x minus 2 equals 3. Okay, so how do we start off with a problem like this? Well, we can just do reverse Pemdas, right? That's how we solve these kind of one-step, two-step equations. Okay, the first thing that we'll do is add 2 on both sides, right? Because our goal here is to get that x by itself. So we can do that to start off by adding 2 on both sides. Now, why don't we just divide 4? Okay, I think the main mistake people make on a problem like this would be to divide by 4 on both sides. But that would make things even more complicated, right? Because then we would have an x minus 1/2 equals 3/4, and then you're dealing with fractions, and you can still do it, right? But it's just not as desirable, right? It's going to be a lot easier if you add 2 on both sides, okay? And then you have 4x, these 2's go away, and you have 4x equal to 5. Divide by 4 on both sides now. Now you can divide by 4, right? And we're dividing by 4 because 4 over 4 is just 1, right? So we get x equals 5 over 4. All right, so we start off by doing reverse Pemdas, right? Pemdas being parentheses, exponents, multiplication, division, addition, and subtraction. We do it in reverse. We do the addition and subtraction first. We did that, right, with the plus 2. We do multiplication and division next, right? So we divide it on both sides. Okay, so that's how you should kind of think about problems like this. Okay, so moving on to problem 2. Now we want to solve for t, and we have 5 times the quantity t plus 3 equals 2 times the quantity t plus 2. Okay, now the biggest thing I definitely think that a lot of algebra students would kind of get confused about with this problem is that you're not dealing with an x anymore, you're dealing with a t. Okay, so sometimes people have trouble kind of realizing that the exact same things apply to t as with x, right? You can still solve it in the exact same way. I know some people get tripped up with that. I definitely think that, in the beginning of, we always used to solve things with x, now I have t's in here, so what do? I think I initially got confused with stuff like that when I was taking algebra. All right, so just a little bit of advice there. We can start off this problem by distributing this 5. Okay, and we distribute that by just multiplying 5 to the t, right? And then multiplying 5 to the 3. So we get 5t plus 15. That's going to equal, now we distribute the 2. So 2 times t is 2t, and 2 times 2 is 4. Now, we kind of just have what we had before, right? Except we have now this x term on the right side. So, well, we have a t term, not x anymore, right? So, what we have to do first, let's get all our t's on one side. Okay, we'll do that by subtracting 2t on both sides. So this goes away, and we just have 3t plus 15 equals 4. Okay, now all that's left to do is basically what we did in problem 1, right? Subtract 15 on both sides, reverse Pemdas, right? So we're dealing with the addition and subtraction first. And then we just have these 15s go away. 3t equals negative 11. Okay? Divide by 3 on both sides, and you get your answer for t, which is negative 11 over 3. Okay? Now actually, some other advice here with this problem. You know, you're getting this negative 11 over 3. This is kind of a nasty answer, but it's going to happen for, you know, a lot of the problems that you deal with, and you can't always assume that when you have, you know, a nastier answer, like a fraction, or like a fraction and a fraction, or just something that's kind of like gross looking, that it's wrong, right? You shouldn't assume that it's wrong because it doesn't look right, okay? Like if it's, you know, if it's negative 11 over 3 rather than something nice like 2 or 3, right? So that's something that definitely has tripped me up all the way through math. I mean, I'm, you know, even through calculus, I was confused on stuff like that, where this answer just looks a little too gross to be right, but it was right. So definitely don't let something like that trip you up. Okay, so moving on to problem 3, we want to solve for x where the square root of 2x minus 1 equals 2. And we want to list any extraneous solutions. So what does this word extraneous mean? I think that's the main thing that is different about this problem, right? We want to list any extraneous solutions, okay? Now, an extraneous solution is basically just a solution that is not really a solution. So it looks like it's a solution, but when you go back and put it into the original problem, okay, well, now you see that it doesn't actually work. So, and I'll talk about how that comes about in the next problem, okay, and you'll see why. But just know that an extraneous solution is a solution that's not actually a solution, right? When it doesn't work when you plug it back in to your original equation. So let's go ahead and solve this here, okay? And maybe the big thing that would not really, the big thing that would make a lot of students struggle, okay, I was tripping up my words there, is this radical. That's the big thing that would definitely make a lot of students struggle on this problem. And all you have to do here to get rid of this square root, you can just square both sides. Okay? And when you do that, you get rid of this radical, right? Because this thing squared is just rad 2x minus 1 times rad 2x minus 1, right? Which is 2x minus 1. Okay? You can also think about it in another way. You can think about it as 2x minus 1 all to the 1/2, which is what this radical is, okay? And then that is squared, right? And, well, when you have an exponent to an exponent, you multiply them. And so you get 2x minus 1 to the first power, which is just 2x minus 1. Okay, so that's why squaring radicals is a really, really great thing for when you're dealing with a problem like this. So 2x minus 1 equals 2 squared, right? You have to square both sides, and you get 4. Okay? So now you just have basically what you had in number 1. So let's go ahead and solve this. We add 1 on both sides. We get 2x equals 5. And we're going to divide by 2 on both sides. We get x equals 5 halves. All right. So that does it for number 3. Now, it does say list any extraneous solutions. And when you have problems with radicals in them, okay, it's a really good idea to check for extraneous solutions, okay? And I'll tell you why in the next problem, why it doesn't really, matter to something like in number 1. We didn't need to check for extraneous solutions. Those weren't going to pop up there. They do pop up when you deal with radicals, okay? So let's just check and make sure that this solution works. Especially, when we're reminded, hey, check for extraneous solutions. Okay? So, doing our little check here, we have the square root of 2 times, we found x to be 5 over 2. Okay? We subtract 1, and we have to see if that's equal to 2. Well, 2 times 5 halves, the 2's just go away, right? And you just are left with 5 minus 1. Okay, which is 4, right? So you have the square root of 4 is equal to 2, and we know that that's true, right? Because the square root of 4 is 2. So this actually works, and x equals 5 halves is a solution to our problem. Now let's move on to problem 4. So in problem 4, we want to solve for x, where x minus 6 is equal to the square root of x. And again, we want to list any solutions that are extraneous. So again, we have that square root here, okay? So the first thing that we should do is just deal with that square root. Okay, get that out of there. How do we do that though? Well, we just square both sides. Okay? And when we do that, we get x minus 6 quantity squared, which we're going to have to expand that, is equal to x. Okay? So that's really nice. Now, let's expand this left-hand side right here. Okay, and we would get a x squared, and actually I'll draw this out just so we're all on the same page here. We have a x minus 6 times x minus 6 equals x. So we do a x times x, which is x squared, a negative 6 times x, which is negative 6x. We'll have a negative 6 times x again, which is a negative 6x, and a negative 6 times negative 6, which is positive 36. Okay, and that simplifies to be x squared minus 12x plus 36. Okay, and remember, these things are equal to x. Now, how do we solve for x here? Well, all we have to do is just subtract the x on both sides. If you subtract x on both sides, you get x squared minus 13x plus 36 equals 0. This equals 0, right? Since we have this quadratic equal to 0, we can now factor this, okay? And, well, how do we do that? Well, how I like to do it is set up an x chart. Okay, this is how I actually did it when I went through algebra. You put a negative 13 here, a 36 here, and we want to see what two numbers add to be negative 13, and what two numbers multiply to be 36. Okay? After thinking for a little bit, you'll be able to see that it's negative 9 and negative 4, right? Negative 9 plus negative 4 is negative 13, and negative 9 plus or times negative 4 is 36. Okay? So we get a x minus 9, x minus 4 equals 0. Okay? And well, that means that x equals 9 and x equals 4. But wait a second. Before we call these solutions, we have to check that they're extraneous. Okay? And since we're dealing with a square root here, those extraneous solutions could definitely pop up. Okay? So let's try out we'll try out 9. Okay? And I didn't give myself much room here. So what I'll do is just write down here. Okay? If we plug in 9 into this equation here, 4x, we get 9 minus 6 equals the square root of 9. Is that true? Well, yeah, because this is 3 and this is 3. So we definitely know that 9 is a solution. But what about x equals 4? Well, if we plug 4 in, we get a 4 minus 6 is equal to the square root of 4. And already you can probably see that this is not going to work because we have a -2 here and a 2 here. So x minus 4, or x equals 4, is extraneous. And we can denote it as such. But just drawing an arrow to it and saying extraneous solution. Okay? So where do these extraneous solutions actually come from? Right? Well, actually, where they come from with, and I said with radicals is because, you have a plus or minus. Okay, if you take a square root of both sides, you need a plus or minus, right? So you can see that we had like a 2 equal to -2. Well, that's kind of side effects of that plus or minus that would have made both of these solutions true. Let me show you what I mean. And by the way, I'm only showing you this because extraneous solutions were definitely a confusing topic. Like, why did they pop up? That's what I was trying to understand when I was in algebra, right? And I'd rather you not have to memorize this because you have enough things to try to memorize for a test like this, okay? I'd rather you understand it and it kind of come more natural, okay? So let's start to understand where this comes from. I cleared out some space up here, and if we have the squared version of this equation, right? We're not going to be able to go back to this without including a plus or minus, right? Because if we square root both sides, we get x minus 6 equals the square root of x. Okay, and it's not just the square root of x, it's the plus or minus square root of x. We could have, we can plus or minus either side, but we can just plus or minus this side. Okay, doesn't matter. So the reason why we do something like this, okay, is because if you have that plus or minus, now both of these solutions are true, right? So the reason why we have to look for an extraneous solution is because that's not what we have in our original equation. We don't have that plus or minus. We have just a positive square root of x, right? So why did we get this for? Because we were solving this equation that when you square root both sides, it does have the plus or minus, okay? So that's why I'm saying it's a side effect, okay? We weren't solving for this equation, we were solving for this equation, which is very similar to this thing, but it's not exact, okay, right? Because instead of having a rad x, you have a plus or minus rad x. So it's very similar, and the only thing that we need to really check for when we go through something like this is we just have to check for that plus or minus, okay? Or for if we have a square root, we want to check for those extraneous solutions, okay? So moving on to our first question for solving inequalities and absolute value equations. Number 5, we want to solve for x where -2 times the quantity x plus 3 is less than or equal to 3x. Okay, so the only thing that separates this from just a regular equation is that inequality sign. Okay, with that, the only thing we need to be careful about is that we know when to flip the sign and when not to. Okay, so let's go through and solve this problem. Now there's a couple things we could do to start this problem. Maybe we could just divide this -2 to the other side. We could distribute it through. Or we could try to just put the 3x on both sides and then distribute through. There's a lot of different ways to go about this, but I think that the easiest way to start off here is to just distribute that -2. When you go through and do that, you have a -2, and that's a -2x, and then you get -6, and it's still less than or equal to 3x. You don't change the sign at all, right? Because you didn't divide by -2 on both sides. The only time you have to flip the sign is when you multiply or divide by a negative number on both sides, okay? So that's the only time that you have to do that. Now, what we're going to do now is just get our x's to one side. Okay, we can do that by just adding 2x on both sides. Okay, and we get that 5x is greater than or equal to -6. Okay, and we divide by 5 on both sides to get our answer, which is going to be that negative 6 over 5 is less than or equal to x. And you can also write that as x is greater than or equal to negative 6 over 5. Okay? All right, so moving on to problem number 6, we're asked to find the solution set of the absolute value of 3x minus 2 equal to 4. Okay, so we want to solve for x. Now, how do we solve for x when we have absolute value signs? Okay, well, let's just think about this a little bit. Okay, if we have this absolute value sign here, okay, that means that not only can 3x minus 2 equal 4, right? Because that's true, right? If you got a 4 here, right, that would be equal to 4, and that's true, right? Right? And well, I guess you could write it as absolute value of 4 equals 4, right? That just means that 4 equals 4, right? Because 4 is already positive, and all that absolute value sign does is it just makes something a positive value, right? It makes everything in it a positive value. Okay? Or it makes so like if this was the absolute value of negative 4, this would still be equal to 4, right? Because this will make this positive. So you get a 4 equal to 4. Okay? So there's another way that this equation could still be true, right? 3x minus 2 could still equal negative 4 and make this equation true. Okay? So we can say that 3x minus 2 equals negative 4. All right? Now we just have to solve two of these equations, right? Just like that problem number 1. Okay, you see how many times this has popped up now. We add 2 on both sides over here. We get 3x equals 6, and then we divide by 3 on both sides. And we get x equals 2. Okay, so that's one of our solutions. Okay, and then we can solve on this side. So we add 2 on both sides. And we get 3x equals negative 2. Divide by 3. And we get x equals negative 2/3. Okay, so those are now our two solutions. Okay, and they both work. Okay, because when you plug in a negative 2/3, right? Let's plug in that negative 2/3. We get a 3 times negative 2/3. Okay, and we subtract 2 off of that. So we would get a we get a 3 times negative 2/3 is going to be negative 2 because these 3's go away. So we have a negative 2 minus 2, and we know that is, and I'm kind of running out of room here, so allow me to adjust these. Yep. And off of this we get the absolute value of negative 4, right? But we know that that's 4. So that's equal to that is an example of a solution to this equation, okay? And 2 is as well, right? If we multiply 2 in, we get a 3 times 2, which is 6, minus 2 is 4. So that also works. Okay, so you see how we get multiple solutions when we have an absolute value sign. Moving on to problem 7, and now talking about polynomial functions. Okay, we want to list the zeros of the function g of x below, and g of x here is x times the quantity x minus 7 cubed and times the quantity x plus 3, and that's squared. Okay, so we want to list the zeros, right? In other words, what values of x can make this thing 0? Right? Well, the idea here is that, well, anything, and here's the premise, right? 0 times anything is 0. And that is the only way that you can get a 0 out of this equation, right? These things don't add together. These are all being multiplied together. This x is being multiplied to the x minus 7 is being multiplied to the x plus 3. So these things are all being multiplied together. The only way to get a 0 out of this thing is for one of these things to be 0. Okay, or there can be multiple that are 0. So we have multiple solutions for x. How many solutions? Well, we're going to have 3 because we have 3 factors here. Okay? The multiplicity, in other words, the exponent of each of these factors does not matter. Okay? The only time that matters is when you're talking about does it touch the does it touch the x-axis or does it pass through it? That's when multiplicity will matter. Okay? So, and by the way, multiplicity just means how many of, right? So if you have a multiplicity of 2, okay, you're saying, okay, now you have 2x plus 3's. Okay, that's kind of I guess that's a good way of putting it. So, we are going to have a solution be x equals 0, right? Because this x could be 0 and that would make everything 0. Also, this x minus 7, right? If you have x equals 7, then that makes this whole thing 0. What about x equal to negative 3? Well, you get a negative 3 plus 3, and you end up with a 0, right? So, x equals negative 3. Okay? So, that is the answer to problem 7. Now for problem 8, we want to determine the maximum number of real zeros of the polynomial f of x below. We have f of x equals negative 7 x to the 6th plus 4x to the 5th plus 3x squared plus 2. Okay, so how do we determine the maximum number of zeros? All right, well, let's just take a look at a quadratic first. Okay, let's take a look at a regular quadratic. Let's take a look at something like x squared plus x plus 2. Now this isn't, I don't know exactly what this factors to be, okay? And we could find that easily, but, okay, this would factor into 2 separate things, right? And they could be, let's say that they're different. Let's say it's x minus 1 and x plus 2. Okay, and actually that is the factors of this, which is kind of funny. But these are 2 factors because, and you can relate that to this having a multiplicity of, not multiplicity anymore. We're not talking about that. This has an exponent of 2. That's the largest term. That's the degree of this polynomial. Okay, this polynomial has degree 2. So it can have a maximum of 2 real zeros, right? In other words, here our zeros are x equals 1, x equals negative 2. Now, you can't say that for all degree 2 polynomials. You could have something like x squared minus 6x minus, or I believe plus 9, right? And then you have x minus 3 squared. That's the factor of this, okay? And that's only 1 real zero, right? Because this is just x equals 3. Okay, if this thing's equal to 0. All right, that's just x equals 3. So there's only 1 0 there. All right, so not all, but we're talking about the maximum. Okay, so if we're talking about the maximum, then the degree of the polynomial is the maximum number of real zeros that any polynomial of that degree can have. Well, what's the degree of this polynomial? Well, it's the highest power, right? That's what the degree is. So it's 6. So our answer is actually this polynomial. And we're not going to factor it. We're not going to find out. So we're just going to say this polynomial could have a maximum of 6 real zeros. All right? And there you go. That's our answer to problem 8. On to problem 9. We have a 4-part question here, but don't worry, this won't take that long. Okay? For the function h of x equals 2x squared minus x minus 1, we want to do the following. We want to, for a, we want to see if the point negative 1, 2 is on the graph of h. We want to find h of 2. We want to find the x-intercepts of h of x, and we want to find the y-intercepts of h of x. Okay? So let's start off with a. Okay? We can just write a here. Okay? Is the point negative 1, 2 on the graph? Well, negative 1 is our x, and 2 is our y of this point. So we can just plug it into this equation. And well, we don't see, there's no y in this equation. Where do we plug it in? Well, h of x you can rewrite as y, right? So we can say that, right? And this is the only purpose of this h of x thing. Why don't we just say y every time? Because it's nice to nice to see that you have a function of x, and then you can do things like this where you have your notation h of 2, right? So you're plugging in a 2 for x in part b. So that's why we have that h of x notation. It's nice for that reason and some other reasons as well. But that's really all you have to know about that. So we can write this as y and then set y equal to 2x squared minus x minus 1, and we can plug in. So we have a point negative 1, 2, so y is 2, and we plug in a negative 1 everywhere we see an x. Okay, now we are just going to see if this equation is true, because if this equation is true, then we have figured out that negative 1, 2 is on the graph of h. Okay, if it's not, then the point is going to be somewhere like, negative 1, 2 is here, and maybe the parabola goes like this, and it doesn't pass through that point. Okay, so let's actually go through and see if these two things equal each other. Well, negative 1 squared, this thing right here, is going to be 1, so we have a 2 here, right? 2 times 1 is 2. Then we have a minus negative 1, which is a plus 1, and then we have a minus 1 here. So this is definitely equal to 2, and so that checks off. So the answer to A is yes. Now moving on to B, we want to find h of 2. Okay, so we just got to plug in 2 for x. Okay, so h of 2 equals A, and let's remember, so we have a 2x squared, so we'll have a 2 times 2 squared minus a 2 minus 1, right? So this is equal to 2, this is essentially 2 cubed, right, which is 8. Then we have a minus 2 minus 1, so we have that h of 2 equals 5. All right, so we just plugged in a 2 for x. That's what this h of 2, that's what this thing is telling us. Okay, so moving on to C, we want to find the x-intercepts of h of x. And so I don't have to keep looking up, I'm just going to write what h of x is right here. I believe it was 2x squared minus x minus 1. I'll double check. Yes, that's what it was. Great. So the x-intercepts. What is the x-intercepts? Well, let's think about it, right? We have to remember what our axes are, right? This is our x-axis. This is our y-axis, okay? And we're trying to find our x-intercepts. We're trying to find where this thing intercepts the x-axis. So right here, 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 okay? So, well, what do we also know those things as, the x-intercepts? Well, we call them the zeros, right? Because that's where that equation of x is equal to 0. In other words, it's where y equals 0, right? Those are our x-intercepts. Where y is 0, we're on the x-axis, right? Because there's no y component, okay? We're just stuck on the x-axis. So that's why we call them zeros, right? So, moving on. We just set h of x equal to 0, right? We set our y equal to 0. And we can just solve this. We can solve this in a number of ways. We can use the quadratic equation, but since we're not to that section yet, I'm actually just going to challenge you by just saying, hey, factor this. See if you can factor this. Okay? How I would do it is make my life a little bit easier, but also a little bit harder at the same time because we're going to have to deal with fractions. But what I would do is get a coefficient of 1 in front of that x squared. So I would divide this whole thing by 2 on both sides. Okay? So this side is just going to stay 0. And this side, I can just divide 2 to each of these terms. And so I get 0 equals x squared minus a 1/2 x minus a 1/2. Okay? So now how do I factor this here? Well, let's think. I can draw that little x diagram again. And I have a negative 1/2 here and a negative 1/2 here. So what two numbers add to be negative 1/2, but also multiply to be negative 1/2? Okay? See if you can figure this out on your own. All right? Tell me if you can think it. All right? Well, actually, it's 1 and negative 1/2. Okay? 1 minus a half, or sorry, it's negative 1 and a half. There we go. Okay, right. It's negative 1 and a half, because negative 1 plus 1/2 is negative 1/2, and negative 1 times a half is negative 1/2. So it's going to be negative 1 and 1/2. Okay? Meaning that we can say that this is 0 equals to x minus 1 and x plus a half. And so x equals 1 and x equals negative 1/2. And you can verify that these are the zeros with the quadratic formula. Okay? And our last part is going to be D, right? Which is to find the, and I actually don't need very much space for this at all, because finding the y-intercepts is much easier, okay? Because remember that h of x is 2x squared minus x minus 1, right? So this is a function of x. Okay, we want to find where x is 0, right? So if we want to find where x is 0, so we want to find the y values where x is 0, that's what the y-intercepts are, we just plug in 0 for x and see where on, that's exactly how we find the x-intercepts, except we're trying to find where the y is 0, right? Now we're trying to find where the x is 0. So we just, instead of plugging in 0 for y, we plug it in for x. All right, so we get that h of 0 equals, and we just plug in 0 wherever we see an x in this equation. So it'll be 2 times, and you can actually see here that this thing will go away, this thing will go away, and we're just left with negative 1 when we plug in 0 for x. So this thing is equal to negative 1. Okay? And there you go. That is these are your x-intercepts, okay, also known as your zeros. And this is your y-intercept, right? Just like a y-intercept in like a line or something like that, which we'll talk about later, right? The y-intercept is that constant term, okay, the term without an x. Now that that's done, we're going to move on to problem 10. And problem 10 is asking us to write the equation for a parabola that has a vertex negative 3, 5 and passes through the point 1, 2. Okay? Now to do this problem, you're going to have to know vertex form. Okay? But I don't think that really will help you if you don't know what a vertex is, right? What's the vertex of a parabola? Okay? Well, the vertex of a parabola, let's just say we have some graph here, and we have some parabola. Okay, that's actually not a good parabola for this example. The vertex is this turning point of the parabola. Okay, it's kind of like the peak, and you can see it definitely more easily as a peak if I take this and I rotate it. Okay, so you can see it as a peak a lot easier that way. But you get the gist here. That's the vertex, and this vertex we label as h comma k. Okay, and that's where this h comes from and this k comes from. Okay, and that's why this is called vertex form. Okay, so let's get to solving this. Now, when you have to put something in vertex form, the biggest problem is you have to find what this amplitude thing is, this a. All right. And how we do this is we use a point that's on that parabola along with the vertex, and then we get that a, right? So let's plug in. This point gives us our x and our y, and this vertex gives us our h and our k. So we plug in, we get 2, right? That's our y, equals a, that's what we're trying to find, times x, which we know to be 1, minus our h, which is negative 3. We square this, and then we have plus k, which is 5. Okay, so now let's just go through and solve. We get 2 equals a times, we have a 1 minus a negative 3, which we know to be 4. Okay, we're just that means just we're adding. Okay, and so we get a times 4 squared plus 5. Okay, so 2 equals 16a plus 5. We can subtract 5 on both sides and get 16a is equal to negative 3. And divide 16 on both sides to get that a is equal to negative 3 over 16. Great. So now we have what our a actually is. And I wouldn't actually just go about circling that yet. Maybe you just want to underline it because that's not our solution. Okay? And actually, you know what I'll do? Is I'll just start circling solutions in the color of the section. Okay? But I'll circle this one in white because it's not our final solution. Okay? That actually seems like a pretty good idea to me. All right? So how we're going to put this into vertex form, finally, since we have this a, is we're just going to put in our vertex, h and k. Okay? And that'll allow for this parabola to describe any point on this because we're now going to make this a y and a x. Okay, and we're going to leave it like that. We're not going to plug in any points. Okay? So what we're going to do is just write this as y equals a negative 3 over 16 times x minus h. So it's x minus h is negative 3. So since there's already a minus here, this becomes plus 3, right, as we saw up here. So this becomes squared, and we have plus 5 from our vertex. Right, and that is our answer. So now let's move on to problem 11, which is on completing the square. So we want to solve for x by completing the square here. And we have 4x squared plus 8x minus 9 equals 0. Okay? Now, I gotta admit, I didn't make this problem too easy, or definitely not too easy, because you know, I have that 4 in front of the x squared, right? And when you have anything other than 1 as the coefficient in front of x squared, you have to make sure that you get rid of that before you actually complete the square, okay? Right, so you basically need like something like an x squared. You can't have like a 4x squared or a negative 2x squared or anything like that, okay? So what you have to do is divide by 4 on each side. Okay, that's the only way you can do this. And when you do that, you get x squared plus 2x minus a 9 over 4 equals 0. Right? Just dividing by 4 there. Okay? Now, you can complete the square, and how you do this. Here's I think completing the square confuses a lot of students, okay? You were trying to get this into a kind of like a perfect square in a way, okay? And you modify the rest of it. You modify the constant term, okay? That negative 9 over 4 in this case, that's the constant term, right? I say it's constant because it doesn't have an x, okay? You're going to modify that term in order to get a perfect square, okay? Let me show you what I mean. The perfect square that we can form off of here, okay? We're going to make this b over 2, okay? That's going to be what we get. So we're going to have a x plus b over 2 squared. Okay, this b over 2 is important. What's b? Well, think about the quadratic, ax squared plus bx plus c, right? That's what you're used to seeing. B is just a coefficient on the x term. Okay, so deleting all that. B over 2 in this case, 2 over 2 is 1, right? So we have a x plus 1 quantity squared. That's our perfect square. Okay, so, well, we still have this 9 over 4 on both sides, but this equation is no longer equal to this thing. Okay, well, why? Because if you expand this again, if you expand this x plus 1 quantity squared, you get x squared plus, you'd get a 1x plus 1x, so you get a 2x here, and then you'd have plus 1. But that's, and then you, of course, would have a minus 9 over 4 here. But that's not what this equation is saying. This equation doesn't have a plus 1, right? So to make this equation the same as this equation, okay, all we need to do is subtract 1. Okay, now when we expand this, we get x squared plus 2x plus 1, and then that minus 1 cancels this plus 1 out. So we're just left with the exact same thing that we have up here. Okay, but how did I know to subtract by 1 and not some other number? That's because when you square this last term here, right, when you get that 1 times 1, so you get 1, right, that is the extra term, okay, because you're only focused on this when you complete the square, right? So you don't care about a constant term, so that constant term is completely new to the equation, and so you have to cancel it out, and in this case we did it by subtracting 1. Okay, and we're going to do another example of this, so don't worry. If you didn't get it this time, you'll get it in the next problem. But you have an x plus 1 quantity squared equals, and I'm not going to skip multiple steps here. This is just equal to, all you have to do here is subtract, this is a 9 over 4 minus 4 over 4, so this is minus 13 over 4, right? This negative 1 you can rewrite as negative 4 over 4, okay? So, and if you do that, you can more easily see that this is negative 13 over 4, okay? This is equal to 0. So you add 13 over 4 on both sides, and you get x plus 1 quantity squared equals 13 over 4. You can square root both sides, and so you get x plus 1 equals the plus or minus square root of 13 over 4. And then you can just subtract 1 on both sides. So you get x equals negative 1 plus or minus the square root of 13 over 4, which you can actually rewrite as the square root of 13 over 2, right? Because the square root of 4 is just 2. All right? So that's actually going to be your answer. All right? And it's, completing the square, the only place that I feel that students really mess up when they complete the square is when when we did that minus 1 thing, okay? That is where students mess up, all right? Without a doubt, I think that is the number one spot, and I've definitely messed up there before, and it took me a while to understand that, but hopefully I explained it to you in a way where it is understandable now, okay? So let's move on to another complete the square problem, okay? We want to find the vertex of the following quadratic, okay? And how do we find vertex? Well, vertex form, the reason why we complete the square and why we use that method is because that puts something in vertex form, okay? So we're able to find the vertex of a parabola that way. So we can set this thing equal to 0, okay? And actually, we don't even need to do that because we're not finding zeros here. We're finding the vertex. So what we can do is just rewrite this as f of x equals, we're now going to do that b over 2 thing again. Okay, so we have x minus b over 2. B is negative 4, right? So I already have that minus ready. Okay, b over 2 is negative 4 over 2, which is going to be negative 2. So we have a minus 2. Okay, that gets squared. Now we still have this plus 2 here, but remember, this equation is not going to be the same as this one because when you expand this thing, you get an x squared minus, you'll have a minus 2x, so you get a minus 4x, and then you'll have negative 2 times negative 2, which is plus 4. And of course you have that plus 2 on the end, right, from right here. So what is the extra term here? Well, according to this equation right here, okay, that extra term is the plus 4. How do we cancel it out? By subtracting 4. Okay, that's it. So we can combine these things now, and then we're done. We have x minus 2 quantity squared minus 2. Okay, and that's the hardest part of this problem. So now we got to find the actual vertex, right? Which, remember, the vertex is h comma k. And vertex form is that you're going to have f of x equal to a times x minus h quantity squared plus k. Okay, so what's h here? And actually, let's start off with what k is, because h is going to be a little tricky. K, you can see, is negative 2, right? K is negative 2. But what about h? We have a minus h here. Okay, so that's going to definitely confuse some students. I've definitely been confused there before. The answer here is not -2, it's 2. The reason being because this is x minus h, not x plus h, right? So if we say h is equal to 2 and we plug that in this equation, okay, you can actually think of, that's a good way to think about it, to be honest. If you plug in h equals 2 into this equation, you get a x minus 2 squared, which is exactly what we have here, right? So if you plugged in -2, like like some students, I think, like definitely me when I was in algebra, would have assumed, right? If you do that, you plug in a -2, you have a minus -2, right? Because this minus is not part of h, right? H is itself. So you would get an x plus 2 squared. That's not equal to this. So that is the main misconception with the finding h, right? So since our vertex is h comma k, we can write that our vertex, now that we found h and k, is 2, -2. All right. And does that do it for complete the square problems? Yes, it does. Now we're moving on to the quadratic formula, question 13. We are over halfway done with our first 25 problems. So now we are going to use the quadratic formula to find the zeros of f of x equals 2x squared plus 5x plus 3. Okay, the quadratic formula is definitely a really great fail-safe for factoring. Okay, and I'll write down what the quadratic formula is right here. Okay, and there. Okay, so the quadratic formula, there's a song to this. I'm not going to sing it because I don't want to be honest. But this is the quadratic formula. Yeah, if you guys get me to like probably 10K subscribers, maybe I'll sing the quadratic formula song. But otherwise, I'd rather not. It's going to be really awkward because, yeah, I'm talking to you right now, but there's nobody else. I mean, I'm just talking to my phone right now, and there's nobody else in this room. So it's just going to kind of be weird just me singing here a quadratic formula song. So yeah, get me to 10K and then we'll talk. But anyways, yeah, quadratic formula, we know that where's all these b's, a's, and c's coming from? Well, a quadratic function, okay, the general form of a quadratic is ax squared plus bx plus c. I'm not sure why my pen keeps cutting out like that. But yeah, so now we understand where our a, b's, and c's are coming from. We can just write here that a equals 2, right? This a, b equals 5, and c equals this 3. Okay? So plugging into the quadratic formula, we get x is equal to -b. That means -5 plus or minus the square root of b squared. So 5 squared minus a 4ac. So 4 times a, which is 2, and times c, which is 3. And then we have this is over 2 times a, which is 2. Okay, so now we just got to simplify this here. We get -5 plus or minus the square root of 5 squared is 25, and then 4 times 2 is 8 times 3 is 24. Putting that over 2 times 2, which is 4, we can rewrite this as x equals -5 plus or minus 25 minus 24 is 1, so square root of 1 is 1. We get -5 plus or minus the square root. All right, let me just say that again. X equals -5 plus or minus 1 over 4. Okay, and so we get that x equals, we'll have a -5 plus 1 over 4, so we'll get a -4 over 4, which is -1, and we'll get x equals, we'll have a -5 minus 1 over 4, which is a negative 6 over 4. Okay, we can rewrite that also as negative 3 over 2. Okay, and that's how you're going to want to write it to get full credit on a question. Okay, so that is your solution for problem 13, right? 13. Okay, so just finding what A, B, and C are. Okay, knowing what the quadratic formula is, sing the song in your head, get me to 10K and I will too. And then you just plug in and yeah. So moving on to problem 14, we're asking if the roots of g of x, which is 3x squared plus 5x plus 5, are real or imaginary. Okay, so first off, what does imaginary mean? Well, it means that it has I in it, right? So you're taking the square root of a negative number. That's how you get the imaginary number I, all right? And if you're wondering, okay, why do we care about imaginary numbers? They don't exist. I'm learning that right now, actually, and I'm in physics 4, and we are doing some like imaginary numbers and seeing how that stuff works in like waves and stuff. I don't know, it's really gross, but it does have actual applications. Just most of you will probably never have to use them again. Okay, so how do we find if roots are real or imaginary? We use this thing called a discriminant. Okay, and I'll show you where the discriminant comes from. The discriminant is the square root of b squared minus 4ac. Okay, and it's sometimes labeled as like d, so you can just say like d equals square root of b squared minus 4ac. Okay, now if that sounds familiar, you are right. It is familiar because square root of b squared minus 4ac is right here. That's your discriminant. Okay, that's the only way, using the quadratic formula, the only way to get imaginary roots is for you to get a negative under a radical. The only radical in the quadratic formula is the square root of b squared minus 4ac, right? So if b squared minus 4ac is negative, right, then you get a imaginary root. Okay, so you can actually write, maybe you can write the discriminant as b squared minus 4ac, I guess, right? Because if this thing is negative, then you have a problem. If this thing is not, if this thing is positive or 0, then you have real roots. Okay, so let's see what this is. Well, first off, we got to label what a, b, and c are. So a is 3, b is 5, and c is also 5. Okay, let's plug those into our discriminant. B squared means, I don't know what that was supposed to be. 5 squared minus a 4 times a is 3 times c is 5. Okay, and so we get 25 minus a 4 times 3 is 12 times 5 is 60. So we get a negative number, right? We get something negative, and that in this case will be negative 35, I believe. But the point is that we get a negative under the radical, right? Because this thing will be square rooted in the quadratic formula, right? So you'll have square root of negative 35, and then you end up with, you can say this is I times square root of 35. You get imaginary roots. Okay, so that's actually the answer to this problem. Okay, moving on to question 15, and I already have the answer here. Darn it, forgot to erase it. All right, so we want to solve for x here. We have 1 over 6 x squared plus 4 over 3 x minus 2/3 equals 0. Okay, now you already probably took a peek at how I ended up solving this. Okay, what I did was I multiplied everything by 6 here. Okay, but you can use the quadratic formula. You can, try to, well, you'd have to multiply 6 anyway to complete the square, but you can make this easier for yourself. Okay, and a great way of doing that here is by multiplying by 6. Okay, if you multiply this by 6, and if you can multiply the other side by 6 too, of course that doesn't change anything, right? But if you distribute the 6 here, you get a x squared here. You'll get a, well, 4/3 times 6 is going to be a 8x, right? Because you'll have a, this will be a 24 over 3, which you can write as 8x. There's other ways to figure that out as well. And you can have lastly a 6 times negative 2/3, which will be a negative 12 over 3, which is going to be 4, right? So this is going to be equal to 0. All right, now let's try to factor this before we even use the quadratic formula or go through any trouble. Well, two numbers that add to be 8 and multiply to be negative 4. Well, what are they? Well, I can't think of any off the top of my head, to be honest. I have no clue, because, and you can actually see why we have a dilemma here. Because if the only two numbers that are, I mean, the smallest numbers that add up to be 8 is like 4 and 4. And if you multiply them together, they're 16. So you run into a bit of a problem here, and we're going to have to solve this using the quadratic formula. Okay, so we have to label what A, B, and C are, right? A is 1, B is 8, and C is negative 4. Okay, plugging into the quadratic formula, we have that x is equal to negative b, which is negative 8, plus or minus the square root of b squared, which will be, well, I won't get ahead of myself. This will be 8 squared, right? B squared, minus a 4ac. We have a negative here, so we can actually just already write this as positive. Okay, and then we'll have a 4 times a, which is 1, times c, which we already put the negative out there, so we'll just put a 4 here. This will be all over 2a, which is 2 times 1. Simplifying this, we have a negative 8 plus or minus the square root of 64 plus a 16 all over 2. And then we can just simplify further. Here we get a negative 8 plus or minus the square root of 80 over 2. Okay, now we can break this radical down further, okay, because this is not a completed answer. We can simplify this still. Okay, square root of 80 can be broken down into, I'll save you some trouble if you haven't already tried this problem by yourself, which I never even mentioned in the beginning of this video, but trying these problems by yourself before I go through them is a better idea, and it'll help you study a lot more than just me telling you how to do these problems. Okay, so for like the rest of these problems, you should do that. So when you break this up, the square root of 16, you get 4, right? So you have a 4 times rad 5. That's the same thing as saying rad 80. Okay, so rewriting that, you can say that this is equal to negative 8 plus or minus a 4 rad 5, and that's over 2. And simplifying, you can divide everything by 2 and get a negative 4 plus or minus 2 rad 5, and that'll be over 1, so you can just say that that's your answer. Okay, so those are, and you can see now why we weren't able to factor that, because we have a radical here, right? That radical is going to, we're never going to guess a radical, right? That's not how that works. All right, so that's our answer for problem 15. All right, so moving on to our next problem, we're going to be talking now about lines. Okay, so problem 16 is saying, what is the slope of the line y equals 3x plus 5? Okay, so to understand this problem, you need to know that the equation for a line is y equals mx plus b. Now, what is m and what is b? Well, m is the slope, right? And b is the y-intercept. So what is the slope in this equation? Well, remember, it's the m term, right? And m is the one that has the x on it. So you can see here the slope is 3. Okay? So slope equals 3. All right? And if it asks you for the y-intercept, you would say that the y-intercept is 5. All right? Moving on to problem 17, it asks us to find the well, find A, the slope of the line perpendicular to the line 2x plus 4y equals 3, and B, the equation of this line, okay? So, this doesn't look right? We have a 2x plus 4y equals 3. That doesn't look like a line. It is, but we have to make some adjustments in order for this to actually look more like the standard equation for a line, okay? So to put this into slope-intercept form, we're going to need to get y by itself, right? So let's write 2x, and let's also write that we're going to be doing our a here. All right, and we have 2x plus 4y equals 3. Okay, so to get y by itself, let's subtract 2x on both sides. Okay, we get 4y equals 3 minus 2x. We can also write this as negative 2x plus 3. Dividing by 4 on both sides, we can finally get y by itself, and that gives us y equals negative 1/2, right? You can write negative 2 over 4 as negative 1/2 x plus 3 over 4. Okay, so this is now the equation of the line, which is the same thing as this line right here. Okay, so it's the same equation. We just manipulated it to get it into slope-intercept form, right? This is slope-intercept form. Okay, so how do we now find the slope of the line perpendicular to that line? Well, first off, what's the slope of this line? It's negative 1/2. Okay, but how do you find the slope of a line perpendicular? Well, you have to take the negative reciprocal of this slope. Okay, what does that mean, negative reciprocal? First off, what does negative mean? Well, we're going to switch the sign, right? And since this is already negative, we're going to make it positive. But what about reciprocal? What does reciprocal mean? It means that we're just going to flip it, okay? So instead of 1/2, we're going to have 2 over 1, which is 2. So let's do our first step, okay? Let's do the negative part. If we make this negative, we end up getting 1/2, right? Because it's already negative. And if we do the reciprocal, then we get 2 over 1, which is just 2. In 2, since we now have done the negative reciprocal, that is the slope of a line perpendicular to this line right here. Okay? So that's the answer for A. Now let's move on to B. B is asking us to find the equation of this line that is perpendicular to 2x plus 4y equals 3. Well, what you have to realize here is that there are many equations. There's infinite numbers of equations that you can use to describe this line. The reason why is because you can make your y-intercept anything. It doesn't matter, right? So that might be something that you would get hung up on doing this problem. The y-intercept can be anything because there are an infinite number of lines. Like, let's say I have this line going up through this way, right? I can have a line going up here and it's perpendicular. I can have a line going up here and it's perpendicular. Okay, that might actually have been out of the camera. So like a line here and a line here, right? I can have any lines I want, right? Doing this a little cleaner, let's say my line goes through here. Okay, well, I can have a line here, right, that's perpendicular. I can have a line here that's perpendicular. I can have a line here that's perpendicular, right? So I can have an infinite number of these lines. The y-intercept doesn't matter, okay, because it'll be true no matter what I make the y-intercept. All that matters is I know the slope, which is 2. So we can just write y equals 2x. Y equals 2x will be perpendicular to this line right here. Okay, and just so that's a little nicer, I can point an arrow to here, right? It'll be perpendicular to that line, which is the same thing as this line, but now this thing is in slope-intercept form. Okay, so that's our answer to part B. Moving on to problem 18, we want to find the equation of the line that passes through the points 2, -6 and 1, oh, sorry, not 1, it's -1, 3. Okay, so to do this, right, remember, y equals mx plus b, right? That slope-intercept form, that's a nice equation for a line. And we have to find a couple things, right? To write the equation of a line, we need the slope and we need the y-intercept. The y-intercept is simple enough, right? We plug in all these three things and we get the y-intercept. But we don't know the slope, so we got to find the slope first. How do we do that? Well, we should know that m equals y2 minus y1 over x2 minus x1. Okay? In other words, it's the change in y over the change in x, right? So, what is the 2 and the 1 mean? Well, we just have two separate things of points, right? So we'll call this 2 and we'll call this 1. This is going to be x1 and y1, and this will be x2 and y2. Okay? So, we can write m as y2 is 3 minus y1 is negative 6 divided by x2 is negative 1 and x1 is 2. So we'll have a minus 2. So this is going to be 3 minus a minus 6, which is 9, and a negative 1 minus 2 is negative 3. So our slope here is negative 3. Okay? So that's a great starting point. Now we're going to use that to find our, along with one of these points, it doesn't matter which one, we're going to use that to find our y-intercept. Okay? So let's use negative 1, 3, just because it's a smaller numbers. Okay? So we'll plug in the 3 for y, and we'll plug in the negative 1 for x, and we'll plug in the negative 3 for the slope. Okay? Well, now you see that we'll have a 3 equal to, this is going to be a 3, and we have plus b. So you can see here that b is going to be equal to 0. What does that mean? Well, that just means that this equation will just be y equals negative 3x, right? The negative 3 is coming from the slope. And we'll have a plus 0, right? From the y-intercept. And that, of course, is redundant to write. So we can just circle y equals negative 3x. All right, and that is an equation of a line that'll pass through these 2 points. Okay? You can even graph it and to check your work and verify that that's true. Okay? So now we're going to move on to circles, okay, which I definitely think is a place where students have trouble with circles. I definitely think that that's one of the topics that I struggled more on when I was in algebra. But we want to write the equation of a circle with a radius of 4 and a center of 2, negative 3. Okay? So the equation for a circle, okay, is that x squared plus y squared equals r squared, right? And that's kind of the really general form, okay? But that's a circle. So that's a circle with center at the origin, right? So center at 0, 0. Okay? If we want to make this more general, we add some like vertical and horizontal shifts to this whole entire circle, right? Which will end up making our circle have its center at some non-origin point, right? We can write like x minus a squared plus y minus b squared equals r squared. Okay? And this is a circle with center at a comma b. Okay? Now, why is this not negative a, negative b? Well, you have to flip the sign, right? These things are inside parentheses, right? So they're shifts, right? Like just as any other shift would be inside parentheses, right? And because they're inside parentheses, you have to flip the sign, right? That's how that works, right? We've done I'm sure you've done other things like that, like we'll talk about transformations of functions in the next video. So you'll definitely be doing some work with that. So if this doesn't make sense, definitely you'll be going over more of that stuff in the next video. Anyways, we need our center to be 2, negative 3. So 2 is the x point, so we're going to write this as x minus 2 squared, right? And our y is negative 3, so we're going to make this y plus 3. squared. And then we have our radius squared. Our radius is 4. So we square that, right? That's r. This is r. We square it, 16. And that's the answer to our problem. All right? Now we're going to move on to a bit of a more challenging circle problem. Okay? For question 20, we want to use the equation of a circle, which we have written out kind of really nasty, right? X squared plus y squared minus 2x minus 4y minus 4 equals 0. And we want to find the center and the radius of the circle. And then for B, we want to find the equation of a line that passes through the point 2, 5 and the center of the circle. Okay? So how do we get an equation for a circle from this mess? Okay? Well, actually, the answer is to complete the square. So what we're going to do is I'm going to get all our x terms together. Okay, we'll have an x squared minus 2x. And then we'll get all our y terms together, a y squared minus 4y. And I'll just put that negative 4 over to the other side. So we'll call it 4, right? So we add 4 to both sides. All right? So now completing the square. We're going to complete the square for this and this. And the reason why is because now we're going to get something that's of this form, right? Where we have perfect squares, right? Okay, so completing the square here, we get a x. Remember, we have a b over 2. B is negative 2, so b over 2 is negative 2 over 2, which is negative 1. And we square that. Now, what makes this different than x squared minus 2x? Well, you get a x squared minus 2x here, but you also have a negative 1 squared, so you have a plus 1. You have to get rid of this plus 1, so you have to subtract 1. Okay, let's see if you pick up on that a little quicker with this next one. We have a b over 2, so we'll have a negative 4 over 2 is negative 2. And then you will have a 4 out front, so you need to subtract that, and you have a negative 4. Okay, so now you can get rid of these extra terms here. We can add 1 to both sides and add 4 to both sides. And so we get x minus 1 quantity squared plus a y minus 2 quantity squared equals a 4 plus 1 plus 4, which is 9. And by the way, if you're wondering why I'm saying quantity squared, I'm not being pretentious, okay? The reason why I'm saying quantity squared is so you know that it's not just, when I say x minus 1 quantity squared, it's not minus 1 squared, it's x minus 1, because it said x minus 1 quantity squared. Maybe I am being pretentious, I don't know. All right, this is the equation of our circle. So what's the center? Well, it's 1, 2, right? 1, 2, and you have to flip the signs, so instead of being both negative, they're both positive. And our radius here. Our radius is not 9, it is 3. Don't make that mistake. Okay, that's a big mistake that a lot of people make. Okay, because this is r squared, right? So take the square root of 9 to get your radius, which is 3. Okay, moving on to B. We want to find the equation of the line that passes through the point 2, 5 in the center of the circle. Okay, so it passes through 2, 5 in the center of the circle. So this is just like that line of problem that we had a couple problems ago, but now we just needed our center, and our center is 1, 2, and the point on our line is 2, 5. Right? So let's again go and find our slope. That was the first step. Remember, m equals y2 minus y1 over x2 minus x1. Let's call this point 1 and 2. So we have x1 and x1 and y1, and we have x2 and y2. So we have a y2 is 5 minus y1 is 2 over x2 is 2 minus x1 is 1, and so we get a 3 over 1, which is 3. Okay, that is our, I shouldn't be circling that with purple, circle it with white, because it's not our answer yet. So that's 3. That's our slope for this line. Now we got to find the y-intercept, and how do we do that? Well, we're going to plug in to our slope-intercept equation y equals mx plus b. With one of these points, let's just go with 1, 2 because it's smaller numbers. Plug in for y, that's 2. Slope is 3, x is 1. Then we have our b. And so we get 2 equals 3 plus b. Subtract 3 on both sides to get b by itself. We're just going to get b equals negative 1. Okay? So we get our final answer to be y equals a slope, which is 3. We have a x, and then we have a b, which is minus 1. And that is the equation of the line that passes through the center of the circle and just a regular 0.25. All right? Moving on to problem 21. We're 5 problems away from being done here. And these problems are going to probably go the fastest out of any of the sets of 5 that we've been doing. Okay, so don't worry, it's going to be over soon. All right, so properties of functions. We want to find the degree of the polynomial h of x equals negative 2x times the quantity x plus 2 cubed, and we have multiplied by x plus 1. Okay, so what is the degree of a polynomial? What does that mean? Remember we talked about this previously. I don't remember. It was quite a few problems ago. We talked about the degree of a polynomial, right? The degree of a polynomial is the highest power in that polynomial, okay? Which, so if we have a polynomial that's highest power is x to the 5th, right? Well, now we know the degree of that polynomial is 5, okay? So let's try to find what the degree of this polynomial will be. Now we don't want to go out and expand this, right, to try to find out, because this is cubed, right? That's going to be really messy. So all we have to do here is look at the exponents here, right? So this x is to the first power, right? And we know that if we multiply this here, we'll get a x squared. That'll be one of our terms, where we'll have an x squared term. Okay, so if we multiply this thing and this thing, we will get some kind of x squared term. Okay, so if it was that alone, right, if we have some function j of x, which is negative 2x times x plus 1, the degree of this polynomial would be 2, right? And you can even show that by expanding this, because you'll have a negative 2x squared, right? You distribute the negative 2x to the x and to the 1. So you have a negative 2x squared minus 2x. Right, the highest power, you have that x squared, so you have a degree of 2. Now, we don't have that, okay? We know that this combined with this will give us a degree of 2, right? But then we have this x plus 2 quantity cubed. Well, what's the highest power we'll get out of here? It'll be a x cubed, right? If we have this x times x times x, we'll get x cubed. So if that multiplies on to some x squared term, right, and let's say that these are just some random coefficients, a and b, okay? It doesn't matter, so that's what I'm trying to get out with the a and b. I'll take those away because I don't want those to confuse anybody. X cubed times x squared, right, which is the highest thing, or which is the highest term that you'll get out of these two right here. You'll get a x to the 5th term, okay? When you multiply all of these things together, your highest term will be x to the 5th. And so we have a degree of 5. All right. To say that again, just to make sure, the power of x here is 1. The highest power of x that we'll get out of here is 3. And the highest power of x that is right here is just 1, right? This is x to the first power. So you do, 1 plus 3 plus 1, and that's 5. So you have a degree of 5. All right. Moving on to problem 22, we want to find the domain in the range of y equals the square root of x minus 2. Okay, so there's 2 key terms we got to go over here. What's the domain? What's the range? Okay, the domain of a function is all of the possible x's. Okay, so if you have a function that doesn't exist for any negative values of x, then your domain is from 0 to infinity, right? Because it doesn't exist for anything that's from like, 0 to negative infinity, right? So that's the domain of your function, right? So for what values of x does this function exist? Okay? The range is for what y values, okay? So it's the same thing as a domain. Now we're talking about y values. Okay, so let's, first off, we're not going to understand what the domain in the range is if we don't understand what the square root of x minus 2 actually looks like, right? We're never going to find the domain and range that way. So the square root of x, what does that look like? Well, it's this function here, right? That's y equals the square root of x. Okay? But what happens when you put the minus 2 in there? Well, this is, you can think of this as being in parentheses, right? If you think of it as x minus 2 to the 1/2. Okay? So this minus 2 will actually be a horizontal shift, right? Because this is an x, okay, not a y, as it was in circles. Okay, or as we had an x and a y in circles, but when this was a y, it was a vertical shift. Okay, but we have a horizontal shift here, and this is a negative 2, so it's going to shift it 2 to the right. Okay, because we have to do the opposite. So we just get this, and this is y equals the square root of x minus 2. Okay, here, what is the domain? Okay. Well, the domain is from 2, and are we including 2? Well, if we plug in 2 to this equation, that's how we can find out. Okay. Well, we would get y equals 0 here. Square root of 0 is defined, right? We just can't have the square root of a negative number. All right. So we know that we're going to include 2, so we have a bracket. And then this is going to go off into infinity, right? This goes off into infinity. So we can write it like that. And remember, we don't include infinity, so we have parentheses. This is interval notation. And we'll do a quick problem on interval notation again in the next problem if you're confused on this notation. So what about the range? Well, this starts at 0 and we know we're including it, right? Because we can get y equal to 0 by just setting x equal to 2, as we just showed. So we can include 0 in the range. And this y, while it doesn't look like it maybe just because of the way I drew it, this y is going to go off into infinity as well. Why? Because if you plug in an infinitely large x, and you take the square root of an infinitely large number, right? This y will still be infinitely large. Okay? So you can, the y will, this line is going to be increasing to infinity, right? Sure, the rate of increase is going to decrease as x increases, right? Well, sorry, that's a lot of words at once. Let me slow down. Okay, as this graph goes, right, the slope of it is decreasing, right, but it's not going to stop it altogether and make it come back down, right? It's still going to go up and up and up and up to infinity. That's a much better way of putting it, I think. Okay, so that's the domain and range, and that's our answer. Moving on to problem 23, we're going to talk about our interval notation now. So what is interval notation? Well, it's the thing with the brackets and the parentheses, right? When do you have brackets? Brackets are when you include an endpoint, right? And what do we mean by endpoint? What am I saying here? If you are so your endpoints here are -5 and 3. Okay, here though we are including -5 but not including 3. Okay, so -5 will be represented with a bracket and 3 will be represented with a parentheses, which is the next thing I was going to talk about, because parentheses are excluding your endpoint, right? If you can think about it, if it helps you to think about it, we have a parentheses with our infinity because we can't really contain it, right? We're not including infinity because infinity is its own thing, okay? You can't include infinity, right? So moving on, we have -5 being included here, and we know that because x can equal -5, right? Because there's that bar under the inequality symbol. right? The less than symbol. So there's no bar here, so x cannot be equal to 3. It can only be less than 3. So we write this as -5. Actually, I'll write this in white. Write this as -5, 3. Okay? There you go. Moving on to problem 24. All right? We want to write the equation of a polynomial with zeros at x equals 0, 2, -1, and 7 that crosses the x-axis at x equals 0 and x equals -1 and only touches the x-axis at x equals 2 and 7. So what are we talking about here? Well, we're talking about crossing and touching. Okay, so we have some polynomial, and I'm not going to draw this exactly, right? But like it's going to be something like this, right? Where it touches in some cases and then it crosses in others, right? Sometimes it touches, sometimes it crosses. Okay, so when you have these zeros, okay, where you're just touching the x-axis, you have a multiplicity, you have an even multiplicity, right? And here's where multiplicity comes back into play. Let's say that this tick is at x equals 4. All right, well, since it only touches the x-axis here, it doesn't go through the x-axis, we know that we have x minus 4 quantity squared. Okay, and what's another example of this, right? We can think of x squared, that equation, right? Y equals x squared. X has a multiplicity of 2 here, and you can think of this as x plus 0 squared. So you can kind of think of it in this form, right? And when you graph this equation, you don't get something going through the x-axis, it just touches it, right? And you will only get 1 0, which is at x equals 0. Okay, so that's the idea here. And of course, when it crosses the x-axis, you will have a odd multiplicity. Okay, some examples of that. Let's talk about y equals x, right? Which is odd multiplicity because you're talking about x to the first power, right? So that's 1 is odd. And what about y equals x cubed, right? 3 is odd. So you'll get something like this. Well, no, you'll get something that looks like this, right? So it goes through the x-axis. It doesn't just touch it like x squared does. So hopefully that makes more sense. And that's going to really help with us constructing our polynomial, because we'll just set y equal to, and we know that at x equals 0 and x equals -1, it crosses, right? So we can just say x times x plus 1. Remember, we have to switch the signs, okay? So this is not going to be -1, it's going to be +1, okay? If you think back to, setting this equal to 0 and then figuring it out this way, we could see here that if x is -1, this thing will be 0, and so the whole thing will be 0, and you get a 0, okay? So we do have to flip the signs here. Now it only touches the x-axis at x equals 2 and 7. So we're going to have x minus 2, and we're going to square that, okay? Because we're going to give it an even multiplicity, right? Which means we give it an even exponent. And then we have a x minus 7 squared. And that is your answer, okay? You've taken into account that it crosses here, so you've given these things odd multiplicity, right? This is x to the first power and x plus 1 to the first power, okay? And these things have even multiplicity because, I don't know, hopefully I said these are odd multiplicity, not even, but yeah, these things are even multiplicity because they only touch the x-axis at x equals 2 and x equals 7, okay? So that's your answer for 24. Moving on to our last problem in this video. I'll make this a short and sweet one. We're trying to see if f of x equals x squared is 1 to 1. Okay, so is this function 1 to 1? Well, what does it mean for a function to be 1 to 1? And you should probably review 1 to 1 and on to and all that stuff, right? But a function is 1 to 1 if it passes the horizontal line test and the vertical line test. Okay? So what does that mean? Well, it means that if you draw any line through this graph, right? This is the vertical line test. If you draw any vertical line through this graph, it shouldn't touch the graph more than once. Okay? So, does it pass the vertical line test? In this case, yeah, it does, because there's no vertical line that you could draw through this that'll touch this pink line more than once. But what about the horizontal line test? Okay, what about that? Well, if you just draw like a line anywhere, pretty much, except for x equals 0, you're going to cross this graph more than once, right? So this does not work out. Okay, no, it does not pass the horizontal line test. And so x squared, or you can even write f of x, is not 1 to 1. And you can write 1 to 1 like that. You can call it just 1 to 1, however you want to write it. Okay, that is the answer to our last problem for this video. All right, so we're going to have a whole new set of 25 problems for the next video. So hopefully you stick with me through that. We're almost done we're halfway done with our college algebra final review. So definitely, stick through it. Subscribe for more content, and of course, and it helps you also go back and find this channel as well for the part 2 video, because you should take a rest right now. We've probably been going at this an hour or maybe an hour and a half or something like that. So definitely take a rest, take a break from studying, and then go and do the next 25 problems. All right. You definitely don't want to stress yourself out too much by trying to cram all 50 problems into one night. Okay. Besides, you have better things to do. Okay. So anyways, that's going to do it for this video, and I'll see you in the next one.